Now the next one. So oxidation number can be defined as this is a what? A charge present on a particular atom or ion present on what? Particular atoms of an element or ions or compound. So the charge present on a particular what? Atoms or ion. Let me remove where compound. On particular what? Atom of an element or what? Ions is called what? Oxidation number. The charge that present on the particular atom or ion is called what? Oxidation number. Likewise, let me say what? E.g. you have Na plus. What's the oxidation number? Is what? Plus 1. If you have zinc, this, what's the oxidation number that is out there? We call it, let me use calcium. Calcium is what? Is plus 2. I mean, if you have what? Oxygen, 2 minus, other is what? So the charge that is present on a particular atom or ion is called what? So number, and let me put one neutral atom. If you have what? Chlorine. This chlorine is what? Is an atom. Abi? It's neutral. Oxidation number of this chlorine is what? Is 0. etc. So the charge that is present at a particular on a particular atom, we call it what? Oxidation number. And then we have rules of calculating oxidation what? Number. So if we calculate the oxidation number, this oxidation number is the one that is help us to name inorganic compounds. Oh yeah, let us look at the rules. Rules for calculating oxidation number. So the abbreviate of oxidation number, we will use what? ON to denote what? Oxidation what? Number. So let us look at the rules. The first one saying that what? Oxidation number of all elements or compounds on a ground state is 0. Meaning, e.g., example, but of any element on a ground state is what? Is 0. Simply means what? Uncombined state. If you have hydrogen, it's uncombined. The oxidation number of hydrogen here is what? 0. If you have what? Potassium, 0. We have magnesium, 0. And if you have calcium oxide, it's also what? 0. The oxidation number of any element that is uncombined state, combined state is what? Is 0. And if you have what? Let me add more. Cl2, 0. O2, 0. We have potassium chloride, is also what? 0. Oxidation number of what? Any element on a ground state or a compound on a ground state is equal to the what? 0. That's the first rule. The second rule said that what? The second rule states that oxidation number, rule 2. This one is what? I call it what? Rule 1. Rule 2 saying that what? Oxidation number of all ions is equal to the charge on what? On it. The oxidation number of all ions is equal to the what? The charge on what? On it. Look at the sample for that one. Example. Oxidation number of any ions is equal to the charge on what? On it. Take it now. If you have Cl minus, what's oxidation number? -1. If you have what? Calcium 2 plus, what oxidation number is what? 2 what? 2 plus. If you have what? Fe3, what oxidation number? 3 plus. And if you have what? CO3, 2 minus, what oxidation number is 2 minus? Is minus what? -2. If you have what? Oxidation number of NO3 minus, it will give you what? -1. So the oxidation number of any ions is equal to the what? The charge on what? On it. That will be what? The second rule. The third rule states that what? Sum of oxidation number of all atoms in a compound is 0. E.g., we have calcium carbonate. Sum of oxidation number is equal to the what? 0. We have H2SO4 equal to the 0. KMnO4 is equal to the what? 0. So sum of oxidation number of any compound will always equal to the what? 0. Let us look at what? The next rule. The next rule, which is what? Rule 4. States that what? Oxidation number of all group 1 elements, is equal to 1. That is, example, sodium is equal to +1, potassium equal to the what? +1, fraction, cesium equal to the what? +1. All group 1 elements, they are equal to the what? +1. The next one is group 5. Oxidation number of all halogen family, which is what? Group 7 in periodic table, is -1. E.g., we have chlorine -1, fluorine -1, bromine -1, Iodide is also what? Minus what? Minus 1. Then Ogun 6. What? Oxidation number of all oxidation number of hydrogen is minus 1 except in metallic hydride. Like what? Sodium hydride, potassium hydride, calcium hydride, which is what? Is plus 1. Sorry, is plus 1 in metallic hydride, which is what? Minus 1. So the next one is 7. Oxidation number of oxygen is always minus 2, except in peroxide of oxygen is minus 2, except peroxide, which is what? 2O2. Here is what? Which is plus 1. Oxygen is minus 2. In peroxide, 2. 2 plus 0. Mm-hmm. Mm-hmm. Minus 1. So that is all about what? The rules of oxidation what? Number. So now let us use it to what? Let us look at how are we going to apply this rule. Yeah. Take this example. Example. Yeah. Calculate the oxidation number of the following underlying elements. 1. KMnO4. 2. A2SO4. 3. Fe2O3. 4. Calcium 2 minus. Then we have 5. Find Cl2 O7 minus 2. Which one again? 6. Find NO2, this, with this nitrogen. 7. 7 VO2 so asked to find what? The oxidation number of the following what? Early what? Elements. Let me add 2 more questions here, please. 8. Sodium carbonate. 9. Sulfur 8. Yes. Now let us solve it together to know the words. Their solution. What is the first question? We are given KMNO4. We are asked what? To find the oxidation number of manganese. Abi? To find it back to the rules. Potassium is group 1 element. From this rule, oxidation number of all group 1 elements equal to the what? +1. Good. For oxygen, oxidation number for oxygen is what? Is -2. You must apply these 7 rules to solve any question regards to the oxidation number. So KMNO4. What do we have here now? Potassium is plus what? +1. Let me use blue marker. Potassium is what? Plus what? +1. Plus manganate, unknown. Plus oxygen is what? -2. We have how many oxygen here? 4. It will be what? 4 multiplied by what? -2 oxygen. Good. This is a compound. What is the sum of oxidation number of atom in a compound is equal to the what? 0. So everything here is equal to the what? 0. By continuing the workings, we have 1 plus 1 here as 1 plus manganate M plus 4 times this minus 8 equal to 0. So what are you going to have now? You have what? -8 plus 1. The manganate will give us what? -7 equal to the 0. So collect the like terms now. We have what? Mn equal to the what? +7. That is what? The oxidation number for what? For Mn here. So if we want to name this compound now, we can call it what? Potassium manganate. How many oxides? It's all. And potassium manganate 7. Or what? Oxide. Because the oxidation number of what? Potassium here is what? 7. Example 2. We have what? A2SO4. We are looking for what? Sulfur. What is hydrogen? Hydrogen is +1. Have we now? Hydrogen is +1. But 2. We have 2 multiplied by what? Plus what? Plus 1 of hydrogen bracket plus sulfur, which is unknown, plus oxygen is minus 2. 4 multiplied by minus 2, everything equal to 0. 2 times 1 here, we have 2, plus sulfur, plus this we have minus what? 8 equal to the 0. Minus 8 plus 2 to give us what? Minus 6 equal to 0. Sulfur equal to the what? Plus what? Plus 6. So sulfur is plus 6. We can now call it what? We have how many oxygen here? 4. Call it tetra. 4 is tetra. Oxygen we have here is what? Ozo. Tetra, oxo. Sulfur is what? Sulfate. How many? 6. The presence of hydrogen here, according to the Arrhenius theory of acid, we call the hydrogen we have here, we call it what? Acid. That is the name. Tetraoxosulfate 6 acid. So the next one, number 3. What do we have? Number 3 is Fe2O3. As we all know that what? This 2 times F, 2F what? Fe plus oxygen, 3 multiplied by minus 2 equal to 0. 2Fe what? Minus 6 equal to 0. Fe equal to the what? 2F equal to the what? Plus 6. Fe equal to the what? Plus 6 over 2 equal to the what? Plus what? Plus 3. So this compound, we call it what? Iron 3 oxide. We call it what? Iron what? Iron 3 oxide. The name of the compound, we call it what? Iron what? Iron 3 what? Oxide. So the next one. See, it's like I will solve this 4, 5, and 9. You will help me to what? To solve the remaining and put your final answer on the comment what? Section. So the 4 is what? CO3, 2 minus. What is oxidation number? We are looking for carbon. We have carbon plus oxygen is 3 multiplied by oxygen is minus 2. The final one here we work with minus 2. Abi? This carbon, this time this, minus 6 equal to the what? Minus 2. C equal to the what? Minus 2 plus 6. C will give us what? Plus 4. So the compound will be, oxidation number for carbon here is what? Is plus 4. And the next one is, let me solve this. Which one again? Which one should I choose? Let me solve this. It's a little bit complex. Number 5 is Cr2O7 minus 2. So we are looking for the chromium there now. So it will now have what? 2 chromium plus oxygen is minus 2. 7 multiplied by minus 2 of oxygen minus 2 here. You have 2 chromium. 2 times this. It gives us minus 14 to be minus 2. 2 chromium equal to the what? Minus 2 plus what? 14. If we add it together, 2 chromium give you what? Plus 2. Sorry? Plus 12 divided by 2. Chromium give us what? Plus what? Plus 6. This is what we have here. So you can solve this and this one. Let me solve the next one. The last one, which is number 9. The number 9 give us what? Sulfur 8. You are now asked to find the oxidation number for sulfur from the rules. We say that what? The oxidation number of any element on the ground state equal to the what? 0. So the oxidation number for sulfur here, S what? S8 is equal to what? 0. Therefore, the compound is still what? Remain sulfur. Please solve the remaining question and tell me the answer on the comment. Solve the remaining question and tell me the answer on the comment what section. I will mark it. So the next thing that we are going to what? To treat now is what? Oxidizing agent and reducing agent. Now we have done oxidation and reduction reaction. But what are the substances that is make oxidation to occur? What are the substances that is make reduction to occur? So the substance that is make oxidation to occur are called oxidizing agents. The species or substance that is make reduction to occur are called reducing agents. That is our next word subtopic we are going to treat. After that, we will now treat what oxidizing agents and reducing agents. After that, we are going to do what we call redox reaction, and how are we going to what to identify redox reaction, and how are we going to balance them.